Welcome everyone to my channel Space Remote Sensing and GIS. So today we will going to discuss a very interesting topic about how you going to do the volcanic eruption analysis. Okay, when it is happen. Okay, so what is the base sensor or bed satellites, which bands we are going to use. So I will going to discuss detailed informations regarding that. Okay, so sorry to you all, like last 1 month I was in a vacation mode and then health was not good, so there is a little delay to upload all the videos. So from today onwards again you will get my videos, so please be in touch and give your comments. So let's start with the analysis of a volcano. So like, see, whenever there is kind of incident will happen, then first thing which will be in your mind, that is what is the data it will be suitable for the analysis. The very first, as is a volcano, there is a smoke, so many conditions will be there. So first options will be the SAR images. Okay, so if you see the SAR images, this is first image which I showed you, that is the part of Indonesia one volcano. Okay, and you see in the SAR images it is fine to understand somehow, like the volcano, and there is a few lava flows is also happen, which may be possible to detect using a different technique. And yes, definitely there is a damage assessment also. It will be good for that also, if you take the before and after image. Now the next options, like suppose which one will be give you the better informations. So in that case you can go with, if multispectral data sets will available, okay, then I think obviously the multispectral will be give you the better option. Why? Because you can detect the smokes. If you see this image of SAR, there is a no smoke, and like if you have options for, suppose you have options for multispectral image, because as I showed you in the multispectral image, you have you can detect the smokes, like where the smoke is going. Okay, so that it is called as a plume. Okay, so you may not understand it is as a plume. Okay, but when I finish my analysis, then you can understand this is actually the plume. So this plume informations is missing in this particular SAR image, because SAR can penetrate with any kind of smokes or something, as we know. But sometimes this information is required to understand and for the studies. Okay, so because for disaster preparedness, that smoke where it is going, so we need to give alert on that particular place also. So in that case, the plume detections is very important for volcanic eruption studies. Now once I will go with this, then what I did, I just opened a normal multispectral image of Sentinel-2. This is Sentinel-1, which we just seen here. Now I open the Sentinel-2 image. So if you open a normal Sentinel-2 image, which I open it here as I showed you, so this is MSL2A image. When I select it and then select it OK, and you see this is the image which will come up, and you select it, go to the raster layer, change the band combinations, color infrared, and you see what advantage you will get it here. Here you can see the plumes. Okay, but still it is confused as maybe the cloud. If you see, this is cloud and this is plume, almost similar. Okay, so then there is another problem. Then this is, if in this place where is you can say the volcanic eye, if you want to detect, it may not be visible in false color composite which I created over here. Okay, color infrared means infrared red and green. That is the normal band combinations. Visually we applied that. Okay, now there is then another technique. Now for you can say the volcanic monitoring or eruption from the Sentinel-2, if you want to use the best band combinations, you have to think. The best band combinations is always shortwave infrared based false color composite. That is the best band combinations. We can very easily detect the volcanic eye, and it can show you the lava flow once you will do the burn analysis. Okay, so for that, what kind of band you need to use? So you need to use the band 12, band 11, and the band 4. These are the band combinations. Okay, so what is the band 11, band 12, and band 4? So those, as we just tell you as a band number, but it should be, if you see, this is usually we called as shortwave infrared band combination range. So band 11 is a shortwave infrared band, that is you can say the wavelength is 1610 nanometer, and then there is band 12, that is also you can say the shortwave infrared band. Okay, so the band combinations, as I mentioned, like we need to use band 12, band 11, both are the shortwave infrared band, and the band 4, which is my band, means red band. Okay, so this is what you want. Now the question is, once you are going to add with the this is called band specific value, means basically if you are opening this file mtl.txt, means sorry, not mtl, mtl.mlsd to xml file, this is automatically stacking what it is doing. Okay, so which you seen, which I open it here, this is basically the band combinations of these 4 bands, 2, 3, 4, 8. Why? The same spatial resolution, means 10 meter. Okay, the question is, when you go for this particular shortwave infrared band 11 and 12, so those spatial resolution is basically 20 meter. Okay, so 20 meter image, if you want to open, then you have to go to your same satellite image which you are opening here from this. Not doing that, go to the granules, open it from here, image data. Okay, and this is your 20 meter bands. Okay, so select the bands what you opened. Okay, like band 12, band 11, band 8, and band 4. Suppose this is 4 band is enough to open that. Okay, now what we are going to do? Now we are going to do the stacking. Okay, so you have to organize all the bands which you are open as a 20 meter. See, all I open as a 20 meter. Here you should not do mix match. Okay, with the 10 meter to the 20 meter, all band spatial resolution should be same. So whatever you bands, here I am taking as a more bands, but at least 4 bands is required to create your combinations to identifying the volcanic eye. So for that you can select whatever the bands you want. So just need to select like this. Okay, like control you press in the keyboard and select one by one whatever you want. Okay, so I will select it. Okay, and this is your band 11 and this is the band 12. So once you did that, then come to the images. Okay, and here in the processing you have composite band. So if you click the composite band, what will happen? Now I will going to show you that. So once you click the composite band, so a new image will going to create. Okay, so I already did it for you because it will take maybe few minutes time, but I will show you after composite what it is showing. See, once it is done, okay, the composite image is created. Okay, so this is my image, and the band combinations which you create, like band 12, band 11 and band 4. Okay, so that is what I created over here. If you see, this is the composite band. So if I go here and select it, okay, so this is accordingly you have to organize your band while you are doing the stacking. So you remember which band it is. Suppose band 6 is the band 12. So this is the first band. Okay, then band 4 is your red band. Okay, so that you have to select. Okay, like band 4 is your red band, and then the band 3. Okay, so that is what I selected as my composite band, okay, which is required for my analysis. Okay, that is shortwave infrared 1, shortwave infrared 2, and your green band. Okay, so this is shortwave infrared 1, shortwave infrared 2, and this is the green band. So accordingly I do the stacking. Okay, and now you see, once I did this, so how the image is showing. So this is how the image is showing. Now you can clearly detect the volcanic eyes. So you just see here, we used many kind of satellite data, like SAR images we used, and we try to understand about the volcanic eruption. We used the multispectral data. So in the multispectrals, for the Sentinel there is a different types of bands, special resolutions is there, so you have to understand, like I showed you, if you go with the 10 meter, what is the problem? You can't detect the volcanic ice. But when I go for the 20 meter, where we have more number of bands, like we have the shortwave infrared 1, shortwave 2 bands, so that when I used with the red band combinations, I can very easily detect my volcanic eruption, volcanic ice. Okay, now how we can do the analysis? So doing analysis also, ArcGIS Pro having a very good options to do that. So if you go here, suppose, okay, I will show you, I will take this image as a top so that you can show you now the analysis. Okay, so this, what you need to do, you need to go with the burn area index analysis. So here we have the indexes. If you go to the imagery, okay, if you go with the process, sorry, not process, okay, we have indices. If you see, there's a lot of indices options will be there. Okay, so now what we will going to do it now. So now, as I told you, like here we have options to calculate the burn area index directly. Okay, so how to calculate the burn area index? So you can come, first you have to select the composite bands which you created, okay, and then come to the imagery, okay, come to the indices, and here you have the BAI, burn area indices image. Okay, so I already calculated for you, so I'm just telling you, once these bands will come, so you have to select properly which one is your red band and which one is your infrared band. Okay, so this selection is very important to do that. So once you done this, okay, so if I run it, okay, so then I will get the NBR image. So let's see the NBR results. And see, this is the results which you get after you did the analysis. Okay, so maybe you will see what is this, but this is basically the range of index. Okay, so this index which will be there, and now you have to classify it. Okay, so before classify, you can go for the stretch value, like you can simply go to the symbology. Okay, so if you go in a symbology, okay, so I will just showing you, go to the symbology, and if you go to the classify, okay, and you can see the classes, like you can give a 10 classes or 5 classes, okay, which you see more better information is coming in a what much number of classes. Okay, I will show you the results of the classes so that you can understand very clearly. And here you can see the results. Okay, so what I did, I can just go with the classify, okay, and I will just give a natural break method and give a 10 classes. Okay, so in these classes you can understand very clearly about the present the conditions of different types of you can say somewhere this is basically the volcanic eye, and if you see the second most if you go this range, okay, so that you can understand. See, these two are very high temperature, means basically the burnt, highly burned. So that means these two areas are basically your volcanic eye, and these values are basically your lava flow, the recent lava flow, whatever it is happen. And then accordingly you can go for the fresh lava flow and the burn area, this, and you can categorize others like previously burned also, like that you can understand from the previous time image. This is I am taking only one image, okay, from that also you can very much detail, you can come out with this. Okay, now we can go, if you want to extract, like suppose volcanic ice you want to extract, or you want to extract the lava flow, okay, then nothing, you just need to convert it in a vector, okay, and class wise you can extract the file, okay, so that you can very nicely create a volcanic eruption map. Now if you see from this what I did, okay, so from this I just extracted this raster layer to a vector layer. Okay, so if this is my range of data sets which you seen here. So first what I did, I just extracted this value. If you see here, there is a different number of values you might get it in attribute value. So from this I make it as a classified volcano as compared to the area also. Means for the each classes I just extracted, suppose this volcanic eye, what should be the area. So this is the lava flow is going on, so what should be the area. So old burned area, new burned area, so what is the total area. So like that I can made it as a new you can say the image. Okay, so where you can see the classified the informations is very nicely coming, so that I can identifying the all the areas, different parts also, just like this which I did. Suppose this is active volcano. Okay, see, I extracted, this is the fresh lava flow. You see, I extracted the fresh lava flow. See, fresh lava burn area. So this is the fresh lava burn area, this is the old burn area. So like that I just make it as a classified. Okay, so you obviously you need to do the ground validations to do this analysis. Now one more thing, the plume detections, which is may showing as, you see, as a cloud which is earlier. So how we will going to understand that is as you can say the plume. So it will not maybe understandable in a 2D. So what you need to do, you need to come to the view, okay, and convert it to the global scene or local scene, okay, whatever it you want. So what I already did for you, I will show you the results so that you can understand. See this, okay, so how very nicely I open this informations, and you see this is my volcanic eye, this is how the lava is flowing down, and this is how the plumes are actually moving. Okay, so this is how nicely all the plume is concentrated in eye points, is very clearly understandable. So this is all about the today's analysis. Okay, so this is a very important part of people who are actually doing the disaster management for the volcanic eruption analysis, okay, using your ArcGIS Pro tool. Okay, so ArcGIS Pro is there, okay, obviously it is there, the satellite data is also there. So only thing you have to understand the technique, okay, how you are going to apply different bands, different technique, okay, to extract the informations. That is important here. That's all from my side. So if you have any more questions, so please let me know in the comments, and wait for my next video. Thank you very much all.